Sum and difference of angles identities explained by Justin D'Souza. The learning objectives of this lesson are: find values of sine and cosine by using sum and difference identities, and to verify trigonometric identities by using sum and difference identities. Now let's look into what these sum and difference identities are. They are these. You can see sum identities, difference identities. Sum means addition plus, difference is minus. Now, if you understand one of this formula properly, then the others are simple conversion. You can relate it easily. Sine A plus B. If there is plus for the sine, over here in the middle there is plus. If it's minus for sine only. Whereas for cos, it's the other way around. If it's plus, it'll be minus here. If it's A minus B, then the formula will have plus B. Plus, sorry. And then over here, if it's sine and cos, it changes in each set. This pair, right? Sine A cos B plus sine A is done. So you need to change this to cos A sine B. Whereas if it is cos identities, it'll be cos A cos B. Can you see both are multiplied? First is only cos A cos B minus sine A sine B. Now last one is tan A plus B. Tan A plus tan B divided by 1 minus tan A times tan B. So if it's plus or minus, then it's separated by the addition or subtraction symbol, whereas nothing means it's multiplication. Now we move on to the 16-point unit circle. Now, since you have scientific calculators, this will not be of that much use. But what exactly it is there's 16 points in the sense there are 16 points in the circle, okay, from 0 to 360 degrees. And the values over here, 1, 0, root 3 by 2, comma half, is for cos x and sine x or sine theta. Okay, you can write theta. What does this mean? At what theta? If it is, say, cos 0 degrees, the cos value is 1. Whereas if it's sine 0, it is 0. Now, if you want, say, for example, 60, then cos 60 equals half, whereas sine 60 is equal to root 3 by 2. This is the 16-point unit circle. These are not that difficult to remember. Usually, if you don't have your scientific calculators, which if you cannot solve trigonometric angles directly, you need to remember this table. Like you can write this in circle or as table. It's much easier to write in table, and you remember all these different values, and then we solve the problems. And now I will go to a problem. We'll understand why this is used. We have the problem to find sine 105 degrees. The exact value, it's hard to find if you do not have a scientific calculator. Basically, for writing anyways, you need to do this method. So understand at least one problem. If you put in your calculator, yes, directly you'll get the answer. But if you do not have to use the calculator, how would you solve this? See, it's very hard to directly solve for 105. It's very difficult. So we can split this in terms of values that are there in the unit circle. Say, for example, the unit circle was there, right? It started with 0, 30, 45. Sorry, my values are not so accurate. 60, this should be 90, okay? 30, 45, 60, 90. Then we had again 120, it keeps on going by adding 30 over here, then adding 15, then adding 30, 30. So that's how we keep on going. Now this can be split up. When I look at this, I know 100 is close to 60 and 40, but we don't have 40, we have 45, and that's well and good because it's 105 is 60 plus 40. So if I write the sine 105 as sine 60 plus 45, what happens? I can use the identity of sine A plus B, isn't it? What is the formula over here? It is sine A cos B plus cos A sine B. Now this identity can be used. All you need to do is instead of A, you have to use 60, and instead of B, you have to use 45. Here it will be sine 60 times cos 45 plus cos 60 times sine 45. This is the thing. Now to remember sine, there are methods to by heart the unit circle. Say now there's one method. It starts with 0 for sine. At 0 0, then it'll be 1 by 2. It's root 1 by 2, root 2 by 2, root 3 by 2, and it keeps on going and becomes 1. It's a root 4 by 4, that will become 1. Let me just show you the unit circle for a minute. I'll just remove this and then get it back. Now you can see over here sine, what happens? It's 0. At 30 degrees, it's root 1 by 2, that is 1 by 2 itself. Over here you can see root 2 by 2, it's root 3 by 2. Here it's root 4 by 2, that will become 2 by 2, that's 1. And then now you need to, once you remember these, just change it up. What do you change over here? Root 3 by 2, 2 by 2, half, from here to here. And then over here, the sign changes and everything, depending on the quadrants. Now, if you're thinking about cos, see cos 0 is over here. Next is half, root 2, root 3 by 2. So you can remember this. That is the point. With this unit circle, you need to find the sine 105. Now, if you cannot remember this, it's fine. You can just use the calculator. But let me just write it. Yeah. So it'll just take you some time. Once you know it, it'll be always there forever. Sine 45 will be root 2 by 2. This is root 3 by 2. Whereas cos 45 and sine 45, 45 degree both are same. It's a root 2 by 2 plus cos 60 will be half. Okay, it starts with root 1 by 2. That's half. And over here it is root 2 by 2. This is the values. You can just put this in calculator or solve it manually as well. You will get the answers. Over here it will be 2 times 2 is 4, and over here it is root 6 plus root 2 divided by 4. Now both the denominators are same, so you can write 4 and add them up, root 6 plus root 2. This is your final answer, root 6 plus root 2. We can also check this in the calculator. Here all you need to write is exactly sine 105. The exact value will be obtained. That is root 6 plus root 2 by 4. But this is the actual method to do it. For these problems, this method, you can use calculator. So just write the formula, substitute the values, each values, and get it. But you will need the same method in the later on part in the example 3. So please try to remember this. If it is any other problem, if it was cos, use the cos identity. That's it. This is how we solve it. Now over here, you can try this by yourselves. You can pause the video, try it by yourselves, or you can just use the calculator to check the answer. Here in the calculator, it is negative 120. So it's negative half. You can also solve this by using identity, that's cos A minus B. You can have multiple, numbers taken. Over here, they have taken 60 minus 180 because the difference between this is 120. And negative 120 over here exactly. So this is it. Substitute the values, you will get the same answer. It's just that you need to remember the identities. Now sine over here, you can write it in terms of A minus B. You can do 60 minus 45 and that will be 15. So sine 60 minus 45 and then you can solve, you'll get the answer. But you can do it directly in the calculator and check as well. So this is easier, very easy. The next part, okay, this is a real world problem, and after that there is the identities to be proven. We will first do this real world problem. Let's see over here. A geologist measures the angle between one side of a rectangular lot and the line from a position to the opposite corner of the lot. Whereas the geologist is over here. She is, okay, let's just read it as 30 degrees. Okay. See the opposite side is over here, right, in the rectangular lot, and from position this angle is 30 degrees. Then she measures the angle between that line, this line over here, the middle line, and the point to the property where the river crosses. This is the point where the river crosses. This is 45 given. She stands 100 meters from the opposite corner of the property. Okay, that means from here to here it is 100 meters, this diagonal. How far is she from the point at which the river crosses the property? You need to find from here to here, that's this y distance, okay? This is given in the question. Now with all the given information, we can draw another figure. It's just that some of the values, see 100 meters, it's not mentioned here. And you can find the remaining angle. See, this whole thing is 90 degree. Why? Because it's a rectangle. All the angles are 90. So If this is 45, this is 30, it's 90 minus 45, it's 45, 45 minus 30, it's 15, so this is 15, yes. And then over here, you can see these are what opposite alternate angles, right? 30, 30, this upside. This will be 60. This entire thing, 45 plus 15 is 60. So this will also be 60. Okay, sum them both. Now you have 30, 60, and this is 90 degree, and this hypotenuse is known. Now we have to find this y, this length. We can find this angle is known, this is known. If we know at least one length over here, then we can find y. I mean this or this, but it's not possible to solve this because we have no information whatsoever. So what we will do is this x is there, right? We'll first solve for that. That is from this over here, this triangle, this one, okay? This is 90 degree, x 100, 30, 60. So what you basically have to do over here is write in terms of you know any this hypotenuse, and you know from here the opposite side, so I'll write it as sine. You can write cos as well over here, but I'll just write sine theta. Theta is equal to opposite by hypotenuse. This 30 degrees opposite is x, so it will be sine 30 degree, that is equal to opposite is x divided by 100, the hypotenuse. Take this to the other side, that would mean 100 into sine 30. You can put this in the calculator, you will get the answer. Once you get that answer, let's just do it in the calculator now. It's 100 times sine 30 degrees, it's 50. So x value over here, this length is 50. Now you know this is 50, this is 15, and this is y. Which is the trigonometry identity that can be used? I'll just erase this off. This over here is 50, so it should be straight. Okay, both are so crooked. Here, you know, there's no opposite side. It's the adjacent. Sorry, this is the hypotenuse. Sorry, opposite to 90 degree hypotenuse, and this 50 is adjacent. So what I'll do is I'll write cos theta equals adjacent by hypotenuse, and what you can do is cos 15 degrees is equal to adjacent, that is 50 divided by y, the hypotenuse. Take of y to the other side, that will be y equals 50 by cos 15. Just put in the calculator, you will get the answers. It will be 50 divided by cos 15, close the bracket, and there you go, that will be the answer. That's 51.76. Let's quickly see the answer. We got the same answer, x as 50. Now we are to solve for 15, we use the calculator, yes, but they have used the long method, that is the sum or difference angle identities. Ultimately, it's the same answer. It's to the nearest tenth of a meter, so it's 51.8 meters from the point where the river crosses the property line. See, from this geologist was standing over here till over here, it is 51.8 meters. That's how we solve this real world. The real world, the figure is the most important thing, and it will be told everything, all the values will be told, and the figure also will be given. So please make sure you draw it appropriately, properly, and then solve it up. And that's the answer. You can check it. This is up to you, and you will get the same answer. Now there is a practice problem. It's not same like the previous one, but you can please do try it. Try pausing the video now and try it by yourselves. Let's do it together now. The harmonic motion of an object can be described by x equals 4 cos of 2 pi t minus pi by 4, where x is distance from equilibrium point in centimeters and t is the time in minutes. Okay. Find the exact distance from the equilibrium point at 45 seconds. Okay. So basically, this is the equation that's already given, where this x, right, is giving the distance from the equilibrium point in centimeters. Now over here, they have given you a time of 45 seconds, and you are expected to solve. You're expected to solve for the distance after 45 seconds. Now here it is in pi. That means it's in radians. Okay. The most appropriate and the best way would be changing the calculator to radians, because whenever you see cos pi like this, just change it to radian. Or but then that's the thing, and over here it's in minutes, so you just type this in minutes. That would be the thing. Otherwise you need to write pi in terms of 180 degrees. Why we need to write pi in 180 degrees is because pi in terms of degrees is in 180. So I'll do both the methods. I know it's a bit confusing. You can directly solve it up, direct substitution, write this formula, substitute and solve. But one thing is, it's 45 seconds. We need in minutes. 45 seconds is 3/4 minute. Okay, you can just do 45 divided by 60. It will be 3/4. This is one important thing you need to do. Let's write it now. Time t is 45 by 60. So now it's in seconds. Okay, sorry, it's in minutes. It was in seconds, 45 seconds. Now it's in minutes. That is equal to 3/4 of a minute. Okay. Now here x is equal to cos 2 pi into 3/4 minus pi by 4. First, let me use radian mode. Radians. Okay. Radian mode. So how do you do this radian mode? Is in default your calculator is always degrees. If you press shift and then mode, press 4, that is in radians. Now whatever value you put of pi, it will automatically be considered as 180 by itself. Now let me solve it up. Cos 2 pi, that is shift and this symbol over here, times 3/4, 3 by 4, minus, now again it's pi, sorry, it's pi, shift and this symbol, 4. And now you can just close the bracket. Now when you press equal to, this is the answer. Let me, okay, I've forgotten to write 4. I just realized this 4 over here. The question has 4 times that thing. So this is supposed to be the answer. Let me just write the 4 over here. Write the question, entire things, all the constants and the variables. Now we will check answer for 1 minute. Yes, that's the answer. Now another way is, if you don't want to change to radian mode, I'll clear the calculator for now. You can see now it's in degree mode. Default is always degree mode. Now what happens is 4 cos, instead of now instead of putting the mode to radian and everything, what you can do is 2 times pi is 180. Is that clear? Because it's in degree, so everything must be written in degree, divided by multiplied by 3/4, minus, again pi is 180 divided by 4. You can just close the bracket here now, and 4 times, so the answer is same thing. Okay, over here it's just the same thing, it's just that they have converted inside from radian to degree. That's it. So this substitution, now here they have done step by step. This is solved individually and this is converted to degrees and then solved. You can do it anyhow, you will get the correct answer. Okay, you can use the radians directly as well. So to convert from radians to degree, you can just multiply it by 180 by pi, or instead of pi put 180. That will be in terms of degrees. Oh, I forgot to tell you one important thing. The distance cannot be negative. It's minus 2 root 2, right? But we are solving for what? The equilibrium, the exact distance. So here the distance cannot be negative. We are just taking the value in terms of magnitude or positive value only. That is 2 root 2. The distance, exact distance is so much. Now we will verify trigonometric identities. Now we can use sum and difference angle identities to verify lots of different identities, and we will see this one over here. Cos 90 minus theta. How do we solve this? We need to get the right side equal to. Now obviously this is equal to sine theta, it's already told. But how do we prove it up? Here what you need to do is write the identity of cos A minus B. That is equal to cos A times cos B plus sine A times sine B. Why? Because since it's A minus B, over here it will be plus, and cos is always cos together, and then next is sine and sine. Next over here is substitution of the given values. It's 90 minus theta. Theta is unknown value, that's fine, but A is known. You will have cos 90 times cos theta plus sine 90 times sine theta. Remember one important thing, no matter what, in one of the group you will have a theta and you will have a known value, this 90-degree or any other angle known value will be there. You can use your calculators to solve this, but these are so simple. 90 degree is very easy to solve. So let's write the answer. Cos 90 is always 0. Cos theta equal plus sine 90 is 1. And what is remaining? Sine theta. So here 0 times anything is 0 plus 1 times sine theta is sine theta itself. This only one dissolved. So it is basically sine theta. That's the answer. And yes, that is what we have to prove. That's it. That is how we solve this. It's pretty easy once you know the formula, just substitution. If you can't directly get the values, you can use the calculator and then get the answers. So these are the steps. Now what about pi by 2? Here, if I am asked to solve this, what I would first do is instead of radians, I'll convert to degrees. And then it'll be much easier. Just substitute over here 180 divided by 2, it's 90 degrees. So I know it's sine theta plus sine of theta plus 90 degrees. This is the thing. It should be cos theta. Let's use the sum identity for sine. Sine A plus B, that is equal to sine A cos B plus it's cos A sine B. It'll be cos A sine B. Now, all you need to do over here is substitute the values. This is sine theta plus 90. Instead of A, I have to put theta, and instead of B, we have to put 90. And then the formula as it is cos theta, and then we have sine 90. Now let's solve this up. We know cos 90 is equal to 0. Sorry, yeah, this is 0, so this goes off. Sine 90 is 1, so you will remain with cos theta only. And that is what we had to solve. Yes, it is correct, cos theta. This is how we prove it. Please do try the other. This is it. Please do try this check problems by yourselves. You can use in terms of degree or radians, but I would personally suggest you just go with degrees. It's much easier. If you're very confident with radians, then go ahead. Please pause the video and try to do it by yourselves now. I will do it over here now. I directly write the formula. I know the formula for A minus B is sine A, that is sine 90, into cos B minus cos, let me just take it off. It's cos 90 times sine theta. Sine 90 is 1, that will be 1 cos theta minus cos 90 is 0. And that will be multiplied by sine theta, it will be 0 itself. This is gone, so you're remaining with cos theta itself. And lastly, we have, this is the answer. And lastly, the same thing over here, we have done similar one. Please do it by yourselves now. One more thing you can realize over here, the previous ones, sine and cos, it's just the difference of the angle, 90 degrees, isn't it? So this is the thing. If you're thorough with the graphs of sine and cos, you will realize, yes, obviously this is true. Okay, now we will do this last one. I'll just do it quickly. You can try pausing the video and doing it by yourselves in the meantime. Here it's an A plus B. I'll just write it directly. You should write cos A cos B first together, and if it's plus for cos, it'll be minus here. And now we have sine 90 sine theta, sine 90 and sine theta. And over here cos 90 is 0, so this part goes off, minus sine 90 is 1, and you're remaining with minus sine theta. This is the answer. So this is how basically you will be solving these identities, proving each identities. Please make sure you write the formula first, then substitute, and then solve just like this. And then make sure both the sides are equal. You do not need to write like, you can just solve it like how I do, one side itself. Anyhow, whichever you're comfortable, follow that method. That's the end of this particular lesson. I hope you found it helpful. Please do subscribe to my channel. It would mean a lot. And please do share my videos with your friends and help others benefit also. And until the next video, stay tuned and wish you all happy learning.